Hello everybody, you are welcome to the e-learning platform. This is a platform for online studies, online learning. My name is Mr. Evans Kwekusim Imbra. I'll be your instructor. I will take you through this course. Today we'll be doing Statics of Solid Mechanics ME 164, or probably you are in electrical geometric, your course code will be KAAF 161. This is for those offering mechanical engineering, civil engineering, electrical engineering, geometric engineering. And I believe that we're going to have a good time. You sit at the comfort of your home and I come to you. And this platform will help you to understand and appreciate the course to the letter. So we'll be starting with the introduction to the course of Statics of Solid Mechanics. Now we'll be looking at the course outline. What would we be doing? We'll be looking at the fundamentals, concepts, forces and moments, equilibrium of rigid bodies, structure analysis, friction, and the last lesson we'll be looking at is simple machines. Simple machines. So we'll go through six major topics, fundamental concepts. We want to understand the various concepts when it comes to mechanics. What is mechanics? What is a force? Newton's first law, second law, third law, the Newton gravitational law. We'll try to understand time, length. We'll look at all those into details. We also look at forces and moment. You know, we want to understand force and how force affects our daily activity. We cannot do without force. When we move, when we walk, it's frictional force in existence. So forces help us. We'll look at what force is, and we'll look at moment. Moment is also one of the topics that we need to understand, the concept that we need to understand. Then we go to equilibrium of rigid body. We want to understand equilibrium of forces, equilibrium of rigid body. You want a body to be in equilibrium. What does it mean when we say that a body is in equilibrium? In equilibrium of rigid body, we'll be able to find unknown forces. We will understand that in equilibrium of rigid body, sum of forces in a respective Cartesian axis is equal to 0. That means that sum of forces in the x direction is equal to 0. Sum of forces in the y direction is equal to 0. Sum of forces in the z direction, provided is what a three-dimensional coordinate you are looking at, is equal to 0. And sum of moment about a point is also equals to 0. We also look at structure analysis into detail. We also look at friction. And we look at simple machines. What is mechanics? Mechanics is a branch of physical science which describes and predicts the condition of rest or motion of bodies under the action of a force. Okay, so you are looking at the branch of physical science that deals with the study of body in motion or at rest. Usually when we say mechanics, our mind goes to the mechanics test. No, that's not mechanics. That's not mechanics. That is a misconception about mechanics. Usually when I introduce the course mechanics to students, their mind, especially Ghanaian students, our mind goes to, are we coming to learn about fitting, automobile? No, that's not what we're going to do in mechanics. As we advance in the course, you know what mechanics entails. Mechanics is basically a branch of physical science that deals with the study of body in motion or at rest. So whenever you want to do a study of body in motion or at rest, you are doing mechanics. Okay, I want to know the mechanics, the forces acting on this body. Why is the laptop still on the platform, on the pulpit? I want to know the forces. It is what? Mechanics. Okay, mechanics. As I begin to move, it's all about what? Mechanics. As you are sitting down there, it's all about what? Mechanics. You are at rest. Now there are branches to mechanics. We have mechanics of rigid bodies. We have mechanics of deformable bodies. We have mechanics of fluid. These are the three subdivisions of mechanics. Mechanics of rigid body. Now in mechanics of rigid body, you assume that the body is a non-deformable body. So rigid body mechanics is a non-deformable body. That is an idealistic concept, because realistically every body, every element, every member undergoes a kind of deformation with time. But when we say that the body is a rigid body, we make that idealization and we say that the body is a non-deformable body. It is not real. Realistically, every body undergoes deformation with time. But to make our analysis simple and our calculation not cumbersome, we assume a rigid body scenario where now we exclude the strength of the material and the property of the material in our calculation and our analysis. Now there are two types of mechanics of rigid body. That is the statics and what? Dynamics. The static body at rest, you are doing a static analysis. That is statics. Okay, static mechanics. You are studying body at rest. And we have dynamics. You are looking at bodies in motion. Now under the dynamics, there are two types. Either you are doing a kinematic studies or you are doing what? A kinetic studies. Now for kinematic is where you are interested in acceleration, velocity, position. Your main focus is not on the force that is causing the motion, but you are looking at acceleration, velocity, position, the geometry. For the kinetics, focus is the force that causes the motion. The force that is causing the motion, that is what? Kinetics. Then we go to the mechanics of deformable bodies. Now, this mechanics of deformable body is the real concept, okay? Where now you are considering deformation. Okay, you are considering deformation. So, under this topic, when you go further or you advance, especially the civil, mechanical engineering student, you will do strength of material 1 and 2. Those courses now look into the mechanics of what? Deformable bodies. Then we have the mechanics of fluid. You know, when water is stored in a tank, that is static, that is stationary. Fluid at rest, hydrostatic. Water stored in a dam, hydrostatic. So you can do a static analysis, okay? And we can also do dynamic. When fluid is moving, water is flowing. We want to know the force the water exerts on the pipe and the force the pipe also exerts on the water. When you do that analysis, you are looking at what? A kind of dynamic analysis too. Okay, so we move on to the basic terminologies in mechanics. What is length? Length is used to specify the position of a point in space and to describe the size of a body or system of bodies. Okay, so that is length. So there's a point in space A and there's another point in space B. What is the position of B from A or A from B? You need to know the length. Okay, so this length will give you that. So length is used to specify the position of a point in space and to describe the size of a body. Okay, this is a phone. If you want to know the dimensions of this, you need to what? Find the length of it. So you take a rule, you can measure the length. We go to time. Time is conceived to specify the order in which a series of events take place or to measure the duration of an event. To measure the duration of an event. Usain Bolt setting the world record for 100-meter sprint. it was set within a specific time. Okay, so time is used to measure the duration of an event. I moved from Kasua to Accra. At what time was the vehicle able to move from Kasua to Accra? When I set my clock or stopwatch, when I get to Accra, I can know whether it was 2 hours or 1 hour or 30 minutes. This is time. So time is used to specify the duration of an event. The next terminology is mass. What is mass? Mass is said to be the quantity of matter contained in a body. The quantity of matter contained within a body. So every body has a certain mass. This phone, I can put it on a scale and I can measure the mass in kg, in kilogram. That is the unit of what? Mass. So mass is the quantity of matter in a substance, okay, or contained in what? A body. Now we go to a force. What is a force? Force is generally a push or pull exerted by one body on another. Force is a push or pull exerted by one body on another. That is a force, a pull or a push. We move on to the next terminology, that is a particle. It has mass but negligible dimension or size. For example, the earth can be modeled as a particle when its orbital motion is steady. When you go to the airport and you look at the planes, you can see how huge it is, you can see the dimensions and the size of it. Now when the airplane is in the skies, you see it as a dot. Okay, you can see the airplane as a dot. You don't see the size, but you can see it as what? A dot. Okay, so a particle can also be defined as a portion of matter so small that is considered as a geometric point. A particle can also be defined as a portion of matter so small that it can be considered as what? A geometric point. Now note that a particle will have one, mass. Okay. 2, particle does not have size. Okay, so a particle has mass but no size. We neglect the size. This helps us to simplify scenarios. When we consider a body to be a particle, that means that we have neglected the size. So this will help us to draw a simple free body diagram by representing the body with just what? A point. So I can be a particle. When we are doing any analysis, and you want to consider me as a particle, that means that you can represent me with what? A dot. And you are right, because I'm a particle. Okay, so you don't have to draw the whole figure. Look at my length and still, no. You just represent me with what? A dot, and that is a particle. So it helps to simplify scenarios, simplify situations. Okay, now we go to a rigid body. What is a rigid body? A rigid body is a collection of large number of particles in which the distance between the particles remain the same before and after applying a load or force. This means that no amount of force is able to change the shape of what? A rigid body. We said earlier on that a rigid body is a non-deformable body. So a non-deformable body means that the body does not deform under any condition. Okay, so no amount of force acting on a rigid body would be able to change the state or form of what? The body. So a rigid body is a non-deformable body. So when you take a body, this is a body, and you pick 2 points, okay, let's say there's a particle A and particle B. Now, this distance will never change under any condition. The mutual distance between this particle will remain the same forever, to eternity. Once it's a rigid body, this mutual distance will not change. But in reality, we know that temperature affects the size and shape of what? Body. Expansion and contraction. So, under real circumstance, this mutual distance undergoes a certain change. But when we say it's a rigid body, we are saying that it will never change. It will remain constant. Okay? It will remain constant. Now we go to Newton's laws of motion. We have to understand the Newton laws of motion. There are 3 laws of motion. The first law, second law, and third law. This laws of motion was established by Newton. So we call it the Newton's law of motion. The first law states that a particle originally at rest or moving in a straight line with constant velocity will remain in this state provided the particle is not subjected to an external or unbalanced forces. This means that a body at rest will continue to remain at rest until an external force is applied onto it. Example, after this lesson, I can choose to leave my phone here. If I don't apply the force, I'm really lazy to apply a force to pick my phone. 100 years to come, provided no external force acts on this building, this studio, my phone will continuously be there. That is Newton's first law. So provided an external force acts on a body which is resting, the body will continue to be there stationary. It also states that a body that is what? Moving in a straight line with constant velocity will do so until an external force is applied onto it. Now, Newton's second law. It says that the rate of change of momentum is directly proportional to the applied external force, and it takes place in the direction of the force. The rate of change in momentum is directly proportional to the applied external force, and it takes place in the direction of the force. So in understanding second law of motion, you need to understand what momentum is. And we know that momentum is equal to what? Mass times what? Velocity. That will give you momentum. Mass times velocity will give us what? Momentum. Now, momentum is largely dependent on what? Velocity and what? Mass. When you take the formula mathematically, momentum is directly proportional to what? Mass and what? Velocity. So as mass increases and velocity is constant, momentum will what? Increase. As velocity increases and mass is constant, momentum what? Increases. Now if I have a body of mass body A and body B. Mass of A is the same as what? Mass of B. But velocity of A is greater than the velocity of B. It means that the momentum of body B, it means that the momentum of body A is greater than body B. Though they have the same masses, but momentum largely depends on the velocity. So momentum is equal to what? Mass times velocity. So let's say I have a twin brother. We are all weighing 50 kilograms, but I'm moving with a velocity of, let's say, 10 meters per second. And my twin brother of the same mass is moving with a velocity of what? 5 meters per second. What it means that I have higher momentum. Okay? I have higher momentum when an elephant is coming with the same velocity of a human being. And you are standing by the roadside. When you crash with the elephant, you know that yes, the elephant has what? Momentum. If it's moving with a human being with the same velocity, but because of the size, it has what? Higher momentum. Now let's go back to our second law. Now, in the second law of motion, mathematically we are saying that the rate of change of momentum is directly proportional. So we go back to variation in mathematics, directly proportional. So the rate of change, that means that momentum changing with time. Momentum changing with time. Momentum changing with time is directly proportional to the applied force. Let's say car A. Okay, the same car. Car A. This car is at Kaswa. The initial velocity of this car starting from Kaswa is U. Within 1 hour, that is 60 minutes, the car gets to Weja, and the car is at Weja with a velocity of what? U. The same car A, the same number of people, the same mass, but the car is moving with different velocity. U is the initial velocity and V is what? The final velocity. Now if you want to find the momentum at point A, okay, so the momentum at point A, that will be what? The mass of the car times what? The initial velocity, which is what? U. This gives us what? The momentum at point A. What about the momentum at point B? That will be the mass, because the mass is still what? The same. So mass at point B times what? Now the velocity here, which is what? The final velocity, which is V. Okay, so this is A. Now what is the change of momentum? The change of momentum mathematically is what? The final momentum minus the initial momentum. So the final momentum is what? MAV minus MAU. That is the change in momentum. But it says that the rate of change, that means that momentum is changing with time. So momentum here, initial momentum, final momentum, the momentum has changed with time. 1 hour, 60 minutes. So with time, T. So the rate of change in momentum is directly proportional to the external force and variation. I bring the proportionality sign and I bring the force. What does it mean? It means that force is equal to, now I can factorize the mass because they are the same. So mass out and out, final minus what? Initial velocity all over time. Now the K, the constant of proportionality K, is equal to 1. So now I have force is equal to mass times V minus U all over T. I'm simplifying further. Now this is common. What is velocity over time? Velocity over time is equal to what? Acceleration. But V minus U over T is equal to what? Acceleration. It means that force is equal to what? Mass times what? Acceleration. So we can define force mathematically from what? Newton's second law. From Newton's second law, we know that force is equal to what? Mass times acceleration. So if you want to find the external force applied on a body, you multiply the mass times what? The acceleration of the body. The mass times the acceleration of the body. Now let's come back to our diagram here. Now this car moved from point A to B. There has been what? A change in what? The location. And this change would definitely be because of what? A force. Force is directly proportional to what? The rate of change in momentum. So momentum changing with time. So I know this, I can get what? The force. Now we go to Newton's third law. Now in Newton's third law, it says that to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. Or for every force acting on a particle, the particle exerts an equal, opposite and collinear reaction force. Now this law is very simple to understand. This law happens in our everyday life. When you throw a football ball to the wall, or when you kick the ball and it strikes or hits the wall, it returns to you. Okay? So there's action and there's what? There is a reaction. Now our fisher folks, when they are paddling the canoe, they paddle backwards. That is the action. But you find out that the canoe moves forward in the forward direction. What is happening? The action and there's what? A reaction. So the reaction is in the opposite direction. Now whenever you sit on a chair, your weight is exerting a certain force on the chair. There's also a reaction force from the chair to your buttocks. That is the reaction force. It's opposite to the action. It's opposite to the action. Newton's law of universal gravitation. What does it say? It states that every two particles of matter having masses m, small m and bigger m, attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distances between them. Every two particles of matter attract each other with what? A force which is directly proportional to the product of their masses and inversely proportional to the square of their distances apart. Mathematically, you have force is directly proportional. Force is directly proportional to the product of their masses. Okay, so product of the masses, and inversely proportional to the square of the distance apart. So you can proceed and remove the sign and bring a constant of proportionality. So the K is now the J. The constant of proportionality is J, where J is the universal gravitational constant. And the universal gravitational constant is 6.673 times 10 raised to the power -11 meter cubic kilogram per second square. Basically, what are we trying to say? So you have a body of mass MA here, another body of mass MB. Now the mutual distance, the distance between these two bodies is, let's say, R. Now from the definition, we are saying that force is directly proportional to the product. So MA times what? MB. So R squared. So you're going to have F is equal to now J MA MB over what? R squared. This is the Newton universal gravitation. So you work it out, you can get what? The G. Weight of a body. The gravitational attraction of the earth on the body is known as the weight of the body. The gravitational attraction of the earth on the body is known as the weight of what? The body. The gravitational attraction of everybody on earth is what? The weight. This phone has a weight. This laptop has a weight. You also have a weight. There's a gravitational pull on you. There's a gravitational pull on you. And it is directed towards the earth, downwards. The weight of the body is vertically downwards. Applying Newton's laws of motion to a body of mass m in equation 5. Remember, in equation 5, force is equal to mass times what? Acceleration. Now this acceleration is now due to what? Gravity. Acceleration due to gravity. So now weight now becomes mass times G. Example number 1. If the mass of a body is 50 kilogram, if the mass of a body is 50 kilogram, find the weight of the body. If the mass of a body is 50 kilogram, find the weight of the body. Remember, we said that weight is equal to mass times what? The gravitational pull, gravity, G. Okay, so the mass is given as what? 50 kilogram. What will be the weight? So we're going to multiply the mass 50 kilogram by what? 9.81 meter per second square. And what do we have for the weight? So we multiply the mass by the weight and we have 490.5 Newton. Remember, force is measured in Newton. Force is measured in Newton. Weight is also what? A force. But this is due to what? The gravitational pull of the body. Units of measurement. Units of measurement. when we're looking at the terminologies, we looked at length, we looked at time, we looked at mass. Now, how do you measure them? You have to measure them with respect to a certain unit. With a certain unit. Now, there are two types of quantities. We have the fundamental quantities and we have what? The derived quantities. Now, for mechanics, we'll be dealing with the three fundamental quantities, which is mass, length, and time. Mass, length, and time. These are the quantities. Now, what are the units of these quantities? If I want to measure mass, which unit would I measure mass in? Is it meters? Is it kilogram? Is it seconds? So the unit is very important. The unit of measurement is very important. When you are measuring mass, you have to measure mass in a certain unit. When you are measuring time, you need to measure time in a certain unit. Okay? Now, the unit of length is what? Meters. The unit of length is meters. The unit of time is second. And the unit of mass is kilogram. Is kilogram. Now force becomes what? A derived unit. And how do we derive the unit of force? It takes us to dimensional analysis. In dimensional analysis, you'll be able to derive the unit for most quantities if you have an understanding of dimensional analysis. In dimensional analysis, we try to achieve dimensional homogeneity. That means that the unit on the left hand side should be equal to the unit of what? The right hand side. Now, in dimensional analysis, it's about you trying to represent all the quantities in the fundamental quantities. So I'm going to use force to briefly go through dimensional analysis and how to derive unit and find unit for various quantities. So force. What is the force? Force is equal to what? Mass times acceleration. So you ask yourself, these quantities, which one of them is a fundamental quantities, or are they all fundamental quantity? Okay, what are fundamental quantities? I know that mass, length, time are all fundamental quantities. Do you have mass? Yes, I have mass. So it means that mass is what? A fundamental what? Quantity. So I represent mass in a bracket, M. Okay? Times acceleration. Is acceleration a fundamental quantity? No. It's a derived quantity. Now, what is acceleration? Acceleration is what? Velocity over what? Time. So you break it down into the fundamental quantities. So acceleration is what? Velocity over time. Is time a fundamental quantity? Yes, of course. Time is what? A fundamental quantity. Velocity. Is velocity a fundamental quantity? No. Velocity is not what? A fundamental quantity. So what should I do? I have to bring velocity what? Down. So what is velocity? Velocity is equal to what? Distance over time. Okay? Distance over time. Okay, distance, is it fundamental quantity? Yes, length. Distance, length. So it's a fundamental what? Quantity. Time, yes, time is also what? A fundamental quantity. So now I write it in terms of dimensions. So instead of writing velocity, I write, because the dimension of distance is what? Length over what? Time, t, and over time in dimensions, t. So mathematically, I have the dimension of mass times the dimension of length, and this is over t. This inverse, okay? So I bring it to the top, it becomes what? T negative 2, because this one comes there, I index this, okay? So I have what? T negative 2. Then you ask yourself, now you've written the dimension of mass, length, and time. So now, what is the unit of mass? So now first, we try to find the unit. What is the unit of mass? Unit of mass is what? kg. What is the unit of length? Meters. What is the unit of time? Second. Then you put it here, minus 2. Are you seeing it? It means that 1 Newton is the same as what? 1 kilogram meter per what? Second square. That is how we derive unit and find unit. So these are examples of various quantities: area, velocity, volume, acceleration, momentum, force. So I will encourage you to work out the unit using dimensions to derive the unit. Now it's very important that we learn how to do conversion. Okay, converting from one unit to another unit. How do you convert 80 kilometers per hour to meter per second? Because sometimes you will not be given the fundamental unit. Okay, you'll be given in kilo, in mega, in different form. But you should know how to do the various conversion. Okay. Now, what is kilo? We know that kilo is 10 with the power 3. Anytime you see kilo, or anytime kilo is represented in the unit, it means that the magnitude is multiplied by what? 10 raised to the power 3. Okay? 10 raised to the power 3. 10 raised to the power 3. So the person said that convert 80 kilometers per hour to meter per second. Now, this is what we do. 80 times 10 raised to the power 3 meters. So now I've converted this one. Now the only unit I have is what? Meters. Okay, over, because I need this to be what? Seconds, not what? Hour. How do you convert from 1 hour, from an hour to a second? How many seconds make an hour? 60 times what? 60. 60 times 60. So this one you have what? 80 times 10 to the power 3 over 60 times 60. What is 60 times 60? 3,600. 60 times 60. 3,600. So you have 80 times 10 to the power 3 over 3,600. What do we have? We have 80 times 10 to the power 3 over 3,600. That is 2.2 meter per second. So that has been solved lovely for us, and that is what we have. That brings us to the end